going to talk about today is the role of Java developers in Gen AI. I think it's a very, very important role, but hitherto it's not been as visible or as important as it should be. I think that's going to change in a really big way. I think we're already seeing it change, but I'm going to explain in detail why I think it will change. Firstly, AI is such a frothy space. It's really hard to keep up. I think a lot of us feel this kind of almost panic. Firstly, it's particularly distracting in enterprise because those of us whose day jobs concern enterprise software are constantly bombarded by AI news, and the things that we are bombarded with are often have very little relevance to what we do. So, one of the first things I think is trying to make sense of what's out there and trying to relate what you hear to what you can actually practically do. And a lot of the emphasis, of course, is on personal assistance scenarios, and they're really quite different from enterprise requirements. Also, of course, much of the AI conversation is driven by people who have no understanding of enterprise and no interest in enterprise. Sometimes I actually think some of these people just hope that it'll all go away and they won't have to worry about it, which of course would be a problem if they want to use, phones, have bank accounts, insurance, all the kind of boring things that make the world run. So when we look at the progress in AI over the last few years, obviously it's astonishing. I think we saw another real transformation probably around December with the latest generation of models for coding, where now coding agents like Claude Code are even far beyond where they were 6 months ago. So clearly we're seeing some amazing things come out, but some things work and some things don't work. The set of things that work is principally the personal assistance style use cases. Turns out that's surprisingly broad. So we started off going to ChatGPT and it didn't really have any ability to call tools in the early days, didn't have any connection to RAG systems or anything. We just relied on its general knowledge, and that was actually quite useful. Then we got tool calling, we got RAG, we got a bunch of ways to ground responses and make them more meaningful. And of course, tools gives us the ability to create side effects. And this enabled things like coding assistance that can modify the file system. It enabled things like research, where it can go off and draft you a terrible blog post based on extensive research, where the research is probably the better part of it compared to the writing. It turns out that personal assistance case is both valuable and surprisingly broad. I wouldn't have thought of coding agents as personal assistants, but essentially that's what they are. This is very amenable to AI because of you. Coding agents are pretty magical, but they're more magical because you sit in front of your machine. So, sometimes they can really blow us away with what they're able to achieve, but you have the ability to say no. You, at least should be, sitting in front of the Git repository and very frequently saying no. And when you say no, you've got this magic get out of jail card. It literally never happened. If you said no and it never even got committed, there is no record of that happening. So we can tolerate quite a lot of autonomy and quite a lot of error in the personal assistance space, right? Because if something is wrong, typically we can make that wrong thing go away. This does not work in enterprise. So for example, Air Canada a while ago offered a customer a ridiculously low fare through a chatbot. They tried to walk it back and they couldn't, because when you are doing a business process, when you're engaging with the public, there are no takebacks. So this is one of the reasons why, although personal assistants are wildly successful, enterprise Gen AI is far less successful, to put it mildly. I mean, I had a slide on all the various surveys, but I took it out because I think we all know that who knows how good the surveys are, but they all say much the same thing, that the results of enterprise AI are pretty disappointing. So why do enterprise Gen AI projects fail? Firstly, there are unavoidable challenges with this technology. So there are challenges that we have to try to mitigate, but we just, we can't magic away. So, for example, this is a non-deterministic technology, and that is something we're not really used to. Like previously, we've always thought about non-determinism as the nasty corner cases, right? Race conditions, things that shouldn't really occur. And even though they're corner cases, they've typically taken quite a lot of our time to mitigate. Now, for the first time, we're dealing with a technology that is inherently non-deterministic. So that, is a big, scary problem that we need to work with. Secondly, as we're all familiar, there's the danger of hallucination. Models love to make things up. And one of the ways you mitigate that is the horrible, horrible thing called prompt engineering. Prompt engineering is basically alchemy. Prompt engineering is just throwing things in like, oh, let's have a bit of lead, maybe some eye of newt. It's really like alchemy where it is not engineering at all. And again, it's unavoidable to some extent, but we can greatly mitigate the problems, and I'll get to how to do that later. Also, of course, is the technology that is slow and expensive to run at scale and very difficult to test and validate. All of these are unavoidable challenges that we need to face and try to overcome. But we're also very good at making challenges for ourselves. So let's not make things worse. One of the avoidable challenges where we make things worse is not knowing what we're doing. This is a really common problem in this space. Any project where you don't have clear goals, where you just want to AI all the things because the board told the CEO to AI all the things and it propagated down the organization, that just doesn't work. I mean, that just cannot work. So, one of the causes of failure, the root cause of failure is people just don't know what they're doing and are trying to do AI for the sake of AI. That absolutely cannot work. What we recommend at Embabel is incremental adoption to try to gradually build up competence within an organization rather than a grandiose strategy to do no one quite knows what. Another avoidable challenge, which is also organizational, is that the wrong people tend to control the AI strategy. So AI strategy often comes out of the data science kind of skill set, and that does not translate well into the enterprise application space, because very often these are people who don't have the right skill set and also don't understand the core business. Another avoidable challenge is what I call the greenfield fallacy. The idea that Gen AI exists in glorious isolation. Like so many blogs you read, whatever it's about, for example, if it's about memory or if it's about RAG, so many of these things are assuming you've got a greenfield problem. So you're assuming that your agent memory doesn't connect to anything that already exists. Memory exists inside enterprises. Your bank has a memory of you, and it's very, very structured. And agent memory should fully engage with that rather than imagining that it's just some new vector store. Again, this comes from the wrong people, and it also reflects the idea that this time it's different. This technology, this wave of technology adoption is going to be completely different. It's nothing like anything in the past. That is not true. No matter how shiny a new technology is, and this one is pretty shiny, no matter how shiny it is, it doesn't change everything. It's how you get to where you want to be from where you are now, rather than, oh, let's forget about what we already have. I spoke earlier about the personal assistance scenario. There are two very different use cases for Gen AI, and I think clearly differentiating them is very helpful. The one that works is personal assistance, and it works partly because of you. We can give agents autonomy because we can cope with failure. And of course, that means they're enabled to succeed by trying more radical things. In business processes, you can't do that. And this distinction, I think, explains the distinction between things that work and things that don't work. With personal assistance, for example, we can rely on giving agents a great deal of autonomy over tool calling. So if you look at how, say, Claude Code works, it's using tools to do all kinds of things. Some of the tools are relatively dangerous because, for example, it might use bash to, I've actually seen it, execute a Perl script using bash. And obviously neither I nor anybody else can read Perl, so I don't know what it did. So it was all in one line though. Yes, you can do anything in one line in Perl. So that kind of approach of great tool autonomy, like give the agent autonomy, throw a ton of tools at it from MCP or other sources, that works fairly well in this model, but it doesn't solve problems in enterprise for predictability. Now let's talk about the lobster in the room as the ultimate example of this. So how many people have actually tried OpenClaw? It's a very interesting project and it has some really good ideas behind it. I personally, although I've looked at it in great detail, I personally wouldn't run it. But I think it's definitely moved the conversation forward. So for example, the idea of an always-on agent is great. That's simply right. The idea of having a gateway that works over all your channels and unifies them, that's great. But as we know, there are a great many security problems, but also there are problems that are inherent in the architecture due to lack of structure, even apart from security. So the way OpenClaw works is all around markdown files. It's all around text. Memory is text. What agents do is text, and it can update essentially its own prompts. So everything is text, and this is illustrative of a lot of approaches that don't really work well in enterprise. Firstly, it makes it unpredictable, right? Because the instructions, everything's just in a prompt. It, secondly, causes excessive token use. So all the prompts to do anything it does are really, really long because it's putting together largely unstructured things. It also means that, as with Claude Code, it needs to do context compression regularly. How many people have noticed that after context compression, Claude Code kind of messes up somewhat? So for example, until I specifically changed the claude.md file, one of the things it used to do for me was become convinced that it was a Gradle rather than a Maven project every time it compressed its context. So, if you're purely working with text, the kind of things that you can do with it are inherently risky and will definitely mess up from time to time. It also means there's a lack of explainability. So clearly that kind of approach is an example of something that's distracting noise that has very limited relevance to how we should work. Okay, so how should we fix enterprise AI, and why are Java developers the people to do it? Well, the first thing that we need to do is start attacking those unavoidable challenges. Number one challenge is non-determinism. So that really is the first thing that we need to think about. We need to make agents as predictable as possible, and the most powerful technique for doing that is breaking complex tasks up. So if you want maximum autonomy, you can do something like give Claude Code in its agentic loop a lot of leeway, let it create its own to-do list and try to knock them off. If you want predictable and repeatable outcomes, you need to break things down into small chunks. And each of those steps should be performed either by an LLM with a very limited prompt and very limited set of tools, or purely in code. Because one of the wonderful things that you can do when you break things up into steps is realize that you don't actually need an LLM to do everything. So for example, you might be able to do an input sanitization step using regular expressions. Some of your steps might be looking up data in existing systems. So the most powerful technique that you can do is break things down, have individual, very specific prompts that are given as few tools as possible to do their work. One of the key benefits of this is that it greatly mitigates the problem of prompt engineering. I spend almost no time worrying about prompt engineering except when writing chatbots. Chatbots tend to be a bit trickier because your prompt does grow bigger, and also you do need to give it fairly detailed instructions on how to respond in, it's a fairly unconstrained scenario of what the user might say to it. So, but with the exception of chatbots, I spend very, very little time thinking about prompt engineering because all of my prompts are about this big. And they're not that fragile. Similarly, you can mitigate the problem of having too many tools in your context and confusing the LLM by having a very specific set of tools passed to do a very specific thing. Finally, you can also choose different LLMs for different steps. And in general, if you're building a non-trivial application and you're using the same LLM for every step, you are absolutely wasting money because you will find that some of the individual steps can probably use a cheaper and faster LLM. So clearly, determinism and ideally deterministic planning of what you're doing is very important. Also, of course, you need guardrails and you need the ability to test what you're doing. All the layers of testing are as important as they've ever been, even unit testing. Obviously, unit testing is not testing what the LLM will do with a particular prompt, but unit testing can spot that you've given the LLM the wrong prompt. So, I have sometimes in the past been frustrated that the LLM's just hallucinating. And then I've seen that I didn't actually send it some critical data in the prompt. So you can absolutely unit test that, and you should. Similarly, integration testing is very important. And one form of testing that's kind of interesting that I noticed that we're doing a lot in our internal applications at Embabel is testing with real LLMs, but fake data. So for example, test containers where we have fake database. Well, it's not a fake, it's an actual database, but it's an ephemeral database, but we're using real LLMs. And that seems to be a pretty important form of testing. Secondly, if you want to succeed in enterprise, you need to integrate with what works. You need to look at where you're starting from and build out from your existing systems rather than build in isolation. This also means ideally that you should leverage proven enterprise infrastructure rather than just stand up new stacks. Again, I've seen the best results come from incremental adoption, building outwards rather than grand strategies that tend to misfire. Thirdly, and this relates very much to the attacking non-determinism, you need to bring structure to your LLM interactions. Don't talk English or any other natural language to your LLM if you can avoid it. So you should be generally asking your LLM to return structured objects rather than text, and you should be building up your prompts using as much structure as possible. This makes everything more predictable, and it also makes it work much better with existing systems. For example, much better ability to integrate with Java applications and to integrate with existing databases. This brings us to a term that I've introduced in my blog last year called Domain Integrated Context Engineering, or DICE. We've heard, so prompt engineering as a term has become less fashionable in the last few months. Now context engineering is the preferred term. Context engineering is definitely an advance, but context engineering cannot succeed in isolation. It needs to be tied into what you already have. And if we're thinking about context, the domain model is incredibly important. I think that domain modeling is getting almost zero attention, at least outside the Embabel community and the Java community in Gen AI, and I think it's incredibly important. And if you can leverage your existing domain model, that's fantastic because it represents what you've already learnt about your business. And of course, when we talk about domain objects, they're objects. They're not just data types. They can encapsulate behavior. And you can even expose tools on domain objects selectively so LLMs can call them. And that's a very, very powerful technique. Structure is really, really important. I think at one end of the spectrum, you've got OpenClaw, where you have no structure and it's really autonomous. At the other end, you have good old-fashioned code, where you've got massive structure and it's not autonomous at all. Pretty much everything you want to do with Gen AI, you need to decide where along that spectrum you want to be. If you're an enterprise, you probably want to be on the right, towards the right, but not every company is quite the same. Not every application is quite the same. So it's something that I think is very, very important to think about every time you are tackling a new problem with Gen AI. How much structure do I want to use? I think in general for enterprise, the sweet spot is mixing code with LLM invocations and breaking things down, as I said, so the LLM invocations are all as specific as possible. But it's very helpful to have this mental map. Okay, how do we play in this world as Java developers? What can we contribute? I think the good news is that we can and should be central. The reason that we should be central is we are adjacent to the critical enterprise knowledge. So we're working in a language where there are now excellent Gen AI frameworks. There's no excuse that, oh, you can't do it in Java. You can do it really, really well in Java. But we also have the core domain models for much of the world's most valuable applications. And we also have the critical infrastructure that makes things reliable, observable, all the capabilities that we know are important. So Java developers really, I think, are positioned to make Gen AI work in the enterprise. And I think their skill set is the critical skill set that's been significantly underemphasized at this point. So how should we actually go about moving this forward as a Java community? Well, firstly, we could imitate what they do in Python. So we could copy Python frameworks in Java and assume that those guys know, or those people know best, and we don't have to come up with any new ideas because apparently we're not smart enough to do this AI stuff. As you can gather, I don't think that's a terribly interesting approach. I think what we should do is look at the problem afresh. Obviously, we should look at prior art on other platforms. And one thing I would say to every Java developer here is you should know Python. Like at this point, Python is sufficiently important that every developer on the planet should be fluent in Python. I've written a great deal of Python, not so much in the last year or two since working on Embabel, but over the last 5 years, I've written a ton of Python. I do think that you should be fluent in Python. And obviously, as we embrace Gen AI on the Java platform, we should be completely familiar with what's done on other platforms. But we should also apply our own experience. So if you look at the success that we've had largely through open source in building up a fantastic programming experience in Java, there's a lot that we know about building application frameworks that is in advance of what you see in other platforms. Like when I wrote all that Python, I have to say I was frequently quite shocked that things that we solved in Spring in, say, 2004, people still do in a really clunky way in Python. So, as a Java community, we've got lots of cool things that enable us to build better. So I think we can apply what we know and do a better job of building Gen AI frameworks. And I think we're already seeing that come to fruition. Let's think in more detail about the Python versus Java comparison. Look, Python has a lot of virtues as a language for certain things. Like I would say, broadly speaking, the more you care about computer science, the less you like Python. So if you are, say, someone who doesn't view yourself primarily as a programmer, Python is actually a really, really good language for you and can make you very productive with limited ceremony. If you are a professional developer working on enterprise applications, things like the fact that Python just doesn't have the concept of immutability might well bother you. They bother me a great deal. So Python is a great language for data science. And one thing that I think we should all do is look at technologies not in an ideological way, but in a pragmatic way. So for example, with data science, if I were training a model, I would do it in Python. I wouldn't, personally, I know there is actually quite some cool work happening on the JVM in this space, but personally, I take the view that that space is great in Python. I'm just going to use Python. So before working on Embabel, I had a project training models to play chess, and just for my own personal interest. And at the time, I much preferred TypeScript to Python and still do. So I tried using TensorFlow in TypeScript. And I fairly quickly discovered that even though TensorFlow is supported in TypeScript, any problem you run into, you can find the solution to it in Python in 5 minutes, whereas it might take you a great deal longer to find resources about it for the TypeScript variant. So, we have to accept that in certain areas of AI, Python is the right choice. But it turns out those areas are not that relevant typically in the enterprise. The one area that really is relevant is ingestion, for example, for RAG. And that, I must admit, I'm a little bit torn because I'm not convinced that it makes sense to try to replicate things like dockling on the JVM. But on the other hand, there is an awful lot of ingestion that you can do on the JVM. So I think, again, it should be very practical and pragmatic as a choice. But we need to be absolutely clear that data science is quite distinct from building Gen AI applications. This is another one of these things that really should be very obvious, but people act like they don't know it or haven't internalized it, which is why I feel it deserves its own slide. So, Python is very good for data science. Python really isn't that remarkable for building Gen AI applications. Okay, so this now brings me to Embabel and what we specifically are trying to do to make enterprise AI better. Embabel is designed to directly address the key Gen AI failure points. So, as you may have noticed, I care a great deal about determinism, and that's like front and center to the design of Embabel, trying to improve that. We put a lot of emphasis on integrating with existing applications. Of course, any Java Gen AI framework, LangChain for J, Spring AI will give you much better integration with existing applications just by dint of being on the JVM. We have a particularly strong emphasis on the role of domain modeling and how to integrate your domain models with your new Gen AI functionality. We make it very easy to mix code and LLM operations and very easy to test flows. The key innovation in Embabel, and it's important to note here that this is not copying anything that exists in Python, this is innovation, is our notion of deterministic planning. So you can either give the LLM autonomy to do everything in its own toollet, right? Throw a bunch of tools at the LLM, let it figure out. That does not scale to address really complex problems in a repeatable way. So therefore, you need to chain together multiple steps. So for example, one of the ways you can see this is in the Python world, LangGraph, which actually uses a state machine, which is a pretty obvious way of doing it. Another way of doing it in the Python world is crew AI, which essentially has sequence of steps, and the steps can compose, so they can kind of nest. So those are obvious ways of doing it, but we think that there is a better approach, and it involves using a much simpler AI algorithm to do the orchestration. This is called GOAP, or Goal-Oriented Action Planning. So we identify a goal that we want to achieve, and then chain together steps that have preconditions and expected post-conditions to get toward that goal. This algorithm actually came from the gaming community. It's one of the most popular algorithms for controlling AIs in games, but it really goes back to AI algorithms from the 1950s around goal-seeking behaviors. So the way in which this works in Embabel is driven primarily by types. So usually the goal is an ultimate type that you want to achieve, and the actions that it chains to achieve that are Java methods, and the actions have a return type and 0 or more parameters. So that enables our planner to work out what sequence of actions you need to invoke in order to get to the goal. I have a session on Embabel this afternoon where I'll show this in more detail, but the key idea is that we believe that orchestration can be driven in a deterministic way based on the type system of the language. And this is another reason that it's good to be in a strongly typed language. This ensures as well that the data that you have at any point available in your flow is congruent with where you are in the flow. So for example, in a state machine like LangGraph, you can orchestrate a flow where what you have in the blackboard at a particular point is not congruent with where you are in the flow, because they're kind of orthogonal concerns that you have to ensure that you have synced up correctly. Can't do that in Embabel because it literally cannot invoke an action method unless it has the correct arguments available to populate it. Embabel is actually really a server rather than just a framework, whereas other frameworks you specifically call a flow. In Embabel, the server knows about everything that's deployed on it. It knows about all the actions, goals, and agents that are deployed on it. And it means that you can actually extend the capabilities of the framework by deploying new actions. So because the planning is done with knowledge of everything that's available on the server instance, if you deploy a new action, it, for example, might make a particular flow more efficient because this action can get you quicker to some future type that you need. The planning is done at runtime, so at invocation time. It also means that if something goes wrong, it can replan. So it plans after every action step. So when it plans, it looks at where it is in its blackboard, what's available, what conditions are true, and the goal, the preconditions it needs for a goal. It executes the first action, then it looks again and replans. Typically, the happy path is, yep, that thing that I chose because it gave me a post condition that I needed, yep, it did it, it's good, let's keep going. But what if it didn't do it? What if it failed? What if it, somehow that expected result was not achieved? Well, then it can replan and may find another path toward the goal. So I think it's a very nice mixture of being quite smart, like smarter than and more flexible than a predefined workflow, but also deterministic because it will always produce the same plan in a particular situation. I've actually got a few slides with code on them, and I'm not sure anybody's going to be able to read them. But this one, there's less code on the other slides, so the others might be more readable. This one you're going to have to take on trust. I think our API is quite beautiful. We've put a lot of effort into it. It's a fluent API. The framework itself is largely written in Kotlin, but we have put a lot of effort into making sure that it's really nice to use from Java. It's actually been an interesting learning experience trying to build a Kotlin framework where most of the usage is in Java. And I would honestly say that it's very easy to do that in Kotlin once you know what you're doing. There is actually less boilerplate code in supporting, for example, the withers that we use in our Fluent API than there would be if it was all written in Java. So yes, the framework is written in Kotlin. Most of our examples are written in Java, and most of our community is using Java. So if you compare using Embabel versus Python frameworks, much more deterministic, really strong emphasis on types. It has the flexible planning versus, hard-coded things like state machines. And it is really easy to integrate with your existing code and run on your existing stack. I have on my Medium blog, I would encourage you to check out, I've got a number of posts from late last year around the theme of you can build better agents in Java than Python. These are really good things potentially to show your manager if they try to get you to say, oh, you have to do your Gen AI in Python. So you could say, oh, have a look at how this is better than LangGraph, or have a look at how this compares with Pydantic AI or Crew AI. So they're quite detailed examples, and they're also open source. So I mentioned that we're not just copying what is happening in the Python world. Let's look at some examples other than the planning where we are actually innovating and doing things that I'm not aware of on any other platform. So one thing that I think is really cool, which is fairly recent, is what we call unfolding tools. So there's a major problem with tools in that they consume a lot of context and they can confuse your LLM. Like every time you add a tool to your prompt invocation, there's a lot of tokens, right? It's very easy in any framework to add tools from classes or methods or whatever, but it's almost too easy when you think about what's happening under the covers because there's a lot of tokens that are going into that request. And also, the more tools you provide, even the smartest models get confused. So we have what I think is a super neat solution to this. Obviously, the first and most fundamental solution to the tool proliferation problem is breaking your flow up into steps, right? That solves it most of the time. But nevertheless, and again, chatbots are a prime offender here, you may end up in a situation where you just do need quite a lot of tools because you don't know exactly what the interaction is going to throw at you. We have the notion of what we call unfolding tools, where you expose one tool and it works like a Russian doll, hence the illustration. And if the LLM invokes that tool, we rewrite the tool calling history to include all the child tools. So for example, imagine, we have a music application, a classical music application that has, amongst other things, Metropolitan Museum tools to pull artworks and information from the Met Museum, Spotify tools to play tracks, do all kinds of things with Spotify. And there's about score search, so to search for sheet music. And all of these things have quite a bunch of tools under them, and most often they're not going to be called. We're able to put them all in the one chatbot interaction because they're all unfolding tools. So for example, rather than have, I think there's somewhere between 7 and 10 Spotify tools, rather than put all of those in the invocation, what we do is say, there's a Spotify tool, call this if you need Spotify. The LLM, if it wants to play a track, calls the Spotify tool. It now sees the tool call history rewritten, where it's got the child tools appearing. So this is a very, very powerful technique, and it's not something that I've seen in any other framework. I don't know, you might be able to read this one. So this is an example. You can define unfolding tools either directly using an API or using an annotation style. This is the annotation style. So we've annotated the class with @unfolding tools. which has a description for what these tools are for. And then inside that class, we have our normal @LLM tool annotation. Very, very powerful, works really, really well. We also use this for Agentic RAG. To use it, it's just like any other tool. So here this was called Met Museum tools. We just say with tool object and get the instance. So the consumption and exposing it to a prompt runner is just the same as any other tool. We also have agentic tools. Agentic tools actually do have a comparison in the Python world called the supervisor pattern. But the way in which we do it, I think, is actually superior and more deterministic. An agentic tool is also essentially a tiered tool, where the top-level tool conceals lower-level tools, but the top-level tool gets to have its own agentic loop and consume the lower-level tools in the order that it pleases. So obviously this is good for encapsulation, but it actually can increase determinism because we've got two fancy versions of it called Playbook Tool and State Machine Tool. And Playbook Tool enables you to say that a certain tool call unlocks other tool calls. So this enables you to have a great deal of control over the tool calling behavior. And again, it works by magically rewriting the LLM invocation history. We also have a State Machine Tool, which is pretty much like LangGraph within an agentic loop. So the first one, I would say unfolding tools have no equivalent in Python or any other framework I'm aware of. And agentic tools are actually a simpler and rather nicer version of a core capability we see in Python frameworks. Defining an agentic tool is pretty easy. You do it using the API. We don't currently have an annotation approach for that. Maybe we should, but you just specify. You could also bring in tools that already exist. So, very often the agentic tool, you're gathering tools that you already have lying around and exposing them for use in this particular scenario. A really important scenario in Gen AI is RAG, Retrieval Augmented Generation. So retrieving information to ground content and guard against hallucinations. The traditional approach to this, which has been around for probably over 2 years now, is a pipeline where you have vector search, maybe hybrid vector and text search, and you make a request based on the context using embeddings, and then you just shove that in the response as part of the prompt. This definitely has its place, but it has some severe and intractable problems. I spent a great deal too much time on traditional RAG pipelines. I read a ton of academic papers. I looked at other frameworks, and I just was not happy with even the fanciest possible pipeline. The reason is fairly straightforward. It's that there's no one-size-fits-all solution for retrieving content. Secondly, chunking is inherently problematic. So when we use a traditional vector search pipeline, what we have done is we've chunked documents up into pretty small chunks. Obviously, you can see the problem, that it's very difficult to ensure that those chunks are complete, and some of them are absolutely not going to be complete. If we make the chunks really big so that they're complete, then we defeat the purpose because we're going to have enormous prompts. So the chunking problem is pretty intractable in a traditional pipeline. So you will get retrievals that aren't really very good because we've only got half of what we need, and there's no real way of mitigating that. Secondly, vector search and text search are completely different in characteristics, and vector search is not the ultimate solution for everything. Imagine that we are exposing RAG against a dishwasher, the handbook for a dishwasher. And imagine that the user says, how do I clean my dishwasher? That will work pretty well with vector embeddings, right? There is notional embedding in vector space, will be around cleaning or whatever. That's almost certainly going to work quite well. What if I say, I see error code 7C, what do I do? That'll probably work because it'll vectorize on error code and go to the relevant part of the documentation. What if I say I see 7C, what do I do? That absolutely will not work with vector search because there's nothing really there to vectorize. You need to do keyword search for that to work. So every scenario is different, which is why the best approach to RAG is not a static pipeline. It's what is called Agentic RAG. And we didn't invent Agentic RAG, it is a concept, but I think we have a really, really nice implementation of it. Agentic RAG is where you're actually giving the LLM more autonomy to do this task. You're saying instead of, oh, you seem to be interested in error codes, here's stuff I found relevant to that. What it does is enable the LLM to call tools and giving appropriate tools like vector search, keyword search, maybe regex search, and also even tools to expand the chunk. So for example, what if the LLM makes a call, gets a chunk back, sees that it's cut off and there was interesting stuff afterwards, give it a tool to actually ask for the next chunk to get a complete result. So we have a very, very nice implementation of Agentic RAG that works across multiple stores. We do it in a very consistent manner in invocations using what we call an LLM reference. LLM references combine prompt elements with tools. So it basically gives you a part of the prompt that describes how you should use the tools, and it gives you a bunch of tools. So this is an example from, I think, the RAGBot project, which shows against a source how easy it is to drop it in. Out of the box, we support Neo, for J, Lucene, the file system, and PG Vector. We also can work with any vector store that's supported by Spring AI. But as I said, if you have only vector search, the results are not going to be that great. Finally, agent memory. This is really one of the hottest topics in early 2026. As I mentioned, the greenfield fallacy is very big here. This idea that agent memory is something that exists in isolation is really quite wrong. At least in enterprise, memory exists grounded in the things that the organization already knows about you. So we have a unified approach to this. It's informed by, amongst other things, the excellent work that Neo technology has done with the LLM graph builder, building knowledge graphs from content. Obviously, there's a ton of work in that space. And also from this paper called Creating General User Models from Computer Use that came out a few months ago, which I absolutely love. It's one of the most interesting academic papers I've read. And that just added something really crucial that I think finally made our knowledge graph memory approach much more powerful. So it's the idea of propositions that are grounded in what we've discovered, for example, about the user, maybe by reading their emails or talking to them in a chat. So the GUM paper had the notion of propositions as these little atomic things, but we have extended it by grounding those propositions in entities. So this comes from the Erbot sample application at Embabel. So here we have a number of facts around the fictional user Cassie Silver. And so, for example, Cassie Silver adopted Artemis from a shelter in 2019. Artemis is the cat. This proposition links to the Artemis and Cassie Silver entity. And there is also a relationship between Cassie and Artemis. Cassie has pet Artemis. So this makes memory much, much more powerful. The notion of grounding it in things that you have. So as you can see, you could ground that. Let's suppose you have a chatbot around a customer. You could link to the customers talking about their trip. Let's suppose you're a travel agency. The customer's talking about their trip to Greece last year. You could actually ground that memory by linking to the trip reference. As I said, this ties into a knowledge graph underneath. So simple, consistent usage model. I know that was a lot to take in from the code point of view, but please come and listen this afternoon and I'll hopefully have more time to go through it. So, points I would like to leave you with. Gen AI needs to be fixed to succeed in enterprise. Java people are the people to do it. Embabel really brings, is not just playing catch up, it really brings innovation. So there's a number of references. What I would really recommend is my Medium blog and going to the Embabel site on GitHub, and I hope I see you later. Thank you.